Okay, we're going to look at our sine waves and our cosine waves, and we're going to start shifting them vertically. Now, just to go over what all these letters mean again, and to point out that I had this wrong in a last video. I said it was plus when it should have been a minus, but we'll get into that. A out in front is the amplitude. This B, after it's been factored out, is the frequency. C is the horizontal shifting, which we're not really going to look at today. We're only going to look at vertical shifting. We'll get into horizontal shifting in a few days. And then here is the bell of the ball. That's what we're doing today, the vertical shifting on the outside. And you remember from 8th grade with the horrible horizontal child, remember we joked around and we said that's the kid in here and he does the opposite of what mom says. And then the kid on the outside here does exactly what mom says. That's the yes child. So yeah, and because it's vertical shifting is going to go exactly up or down, just like the sign tells us. We have a cosine wave. That's what example 1 wants us to look at. Before I graph double it and plus 1, I'm just going to take time and get my mind straight and remember what a cosine wave looks like. All right, well, a cosine wave goes 1 high, so I'm going to designate that spot right there as 1. And then it hits the x-axis. Then it goes 1 low. Hits the x-axis and comes back up. There's my cosine wave. Best I can draw on my little pad here. Now, they want me to double my cosine wave. That's the next step that it's asking me to do, is to double my cosine wave. So I'm in with this blue, I'm going to double each point. So instead of it being at 1, it's going to be at 2. When I double 0, I'm still at 0. When I double -1, I go down to -2. Double 0, I'm still at 0. And I double 2, I'm up here at 1. So what I just drew there was a y equals 2 cosine x. Now I have one last thing to do. It wants me to add 1 onto each of these points that I just doubled. So to do that, if I add 1 on there, then this goes up 1 spot. See, this 2 goes up to 3, 0 goes up to 1, -2 goes up to -1, 0 goes up to 1, and 2 goes up to 3. Voila! I just did y equals 2 cosine x. Now, you would keep going. This is secular, so it keeps going and going. And I could put arrowheads on the end here, but since we're just manipulating this and learning how to do it, I'm just going to ignore the arrowheads for today. All right, so again, example 2. Get your mind straight. The first thing that I'm going to look at is the sine wave. I'm just going to graph a regular sine wave. A sine wave is a hill followed by a valley. Now, what do they want me to do to this sine wave? They want me to take the sine wave and add 3 onto it. That means every one of these points gets added 3. So 0 plus 3 is 3. 1 plus 3 would be 4. 0. And there's my new sine wave. It's a regular sine wave plus 3. All right, now this one. We've got actually 30 things that's going on here. So once again, I'm going to take my time and I'm going to just graph a regular sine wave. A regular sine wave is a hill followed by a valley. Maximum height is 1, minimum height -1. All right, so now what they want me to do to that, they want me to double the sine wave. All right, one thing at a time, I'm going to double the sine wave. So 0 stays at 0, 1 goes to 2, 0 is at 0, -1 goes to -2, and then 0 stays at 0. But I'm not done now. Now they want me to take the negative of that. All right, so I'm going to come back here and I'm going to do some more changes. So instead of 0, negated 0 is 0. All right. Instead of 2, a negated 2 is -2. And then that's 0. And then a negative of a -2 is a +2. And then that's 0. So I'm going to get rid of this green now so it doesn't get in my way. Connect my points. There we go. And I still have one more thing to do. I still have to plus 2 to that. So now this point, plus 2, is going to go up to here. Plus 2 to this, 1, 2 is going to go to there. Plus 2 to 0 is going to go to there. Plus 2 to 2 goes again up to 4 off my graph. And plus 0, plus 2, there is my new sine wave. So yes, that's why I do all my sine waves in pencil, and I do them one at a time, one transformation at a time to keep my mind straight. Some of you will get good at it and be able to do it all at once. But notice, negative means my sine wave is upside down. It has a height, an amplitude of 2. If I take my highest point up here, which is 4, and I minus its low, 0, divide by 2, it's 2. Remember, that's in my absolute value, so my amplitude is still 2. And then everybody got shifted up, +2. All right, so the last one we're going to look at today is the backwards. They're going to give you the sine wave, and this time you have to figure out its graph. So if I come down here, and y equals, I got to figure out its amplitude. I have to figure out its frequency. And then it's shifted vertically. Notice there is no horizontal shift going on here. So I'm going to tackle the amplitude first. The amplitude is simply the highest minus the lowest. Take the absolute value of that and divide it by 2. So 22 minus 6 is 16. Divided by 2 is 8. All right, so over here, I'm going to just keep track of everything. Y equals 8 sine. All right, what's my next piece of work I got to do over here? Frequency. How many waves do you see in 180 degrees? Oh, sorry. How many waves do you see in 360 degrees, or 2 pi? All right, so I'm going to have to come over here and do some thinking. Well, they tell me this is pi right here, and they tell me that this is negative pi right here. So from there to there, that's 180 degrees. Negative 90 to 0 is 90. 0 to 90 is 180. So that means if I went to right there, this must be 180. So this is 270, or 3 pi over 2. And that's 2 pi. 1, 2, 3, 4 90 degrees or pi over 2 intervals. So I see one cosine wave, which is the same as one complete sine wave, just its complement of it. So this b value is 1. Now I'm going to put the 1 there just to hold it so we understand that we addressed that situation. Now comes the plus c. Let's clean this up. So the last thing we have to find is this c value. So that means we had a vertical shift. And if I come back here and get my mind straight, I know a sine wave is a hill followed by a valley. So somebody took this sine wave and shifted it up. So that's what we have to figure out. We have to figure out how far it shifted. Well, the amplitude gives us a clue. When we look down at the amplitude, we know that it was a distance of 16 from its lowest point to its highest point. We took half of that and we got 8. So what I have to do is figure out, there's a couple of ways you can do this. Is if I look at it this way, I can say, well, its highest point is 22. The sine of 90, if I were to stick 90 in here, or pi over 2 as they're calling it, is 1. And then I've got to get it multiplied by 8. So 8 plus what is going to get you to 22? That's right. It's 14. Now, that's one way you can do it. There's another way you can do it. And the other way you could do it involved that amplitude that I was talking about. And it's very simple, simply like this. If we knew the distance from 6 to 22, if we took half of it was 8, then what's halfway between here? Oh, a distance of 8. So 6 plus 8 gets you 14, or 22 minus 8 gets you 14. So that's another way you could have found that halfway point.